I'm going to take a look at tangent and normal lines. So we're going to make a title page, applications of derivatives, and then we're going to make a tab after that. So a title page, cut along all the way down the margin, make one tab. On that first tab, we're going to say tangent and normal lines. So we're going to be looking at applications of derivatives. The first thing we're looking at is tangent and normal lines. Alright, so remember the derivative is the slope of the tangent. I can't say that enough. The derivative is the slope of the tangent. Alright, the derivative is the slope of the tangent line at a particular point. Well, a normal line is a line that is perpendicular to the tangent line. A normal line is a line that is perpendicular to the tangent line. So listening check. Color in derivative is the slope of the tangent. Color in derivative is the slope of the tangent. That sentence is the very first line. We have learned all that we have to be able to solve a basic calculus problem such as. So listening check. Color in normal line is a line that is perpendicular to the tangent line. Color in normal line is a line that is perpendicular to the tangent line. That's the second and third line. Alright, so example 1. The question is, find an equation of the tangent line to the curve y equals 2x plus 5 over x squared minus 3 at x equals 1. Alright, so the very first step that we need to do is you need to find a particular point xy. So if the question only gives you one coordinate, find the other by plugging it back in. Alright, so in this case we're given x equals 1, so we're going to find y by plugging in x equals 1 where I see x. So all I'm doing is put in 1 where I see x. Alright, then evaluate it. I'm going to get 2 plus 5 minus 3, and that's going to give me 4. So the point is going to be 1, 4. Alright, the second step is going to be find the slope, which remember the slope is what? The derivative at that point. Find the slope, the derivative at that point. Okay, so you start off with the equation, and I'm just going to write that x squared as x to the negative 2, so I can take the derivative, and that's going to give me 2 minus x to the negative 3 because I subtract 1 from the top, which is going to give me 2 minus 10 over x to the positive 3. Now plug in that point, you're going to get 2 minus 10 over 1 cubed, which is 1, which is equal to 2 minus 10, which is equal to negative 8. And that's your slope. Okay, so the derivative at that point is your slope. So that's your slope m. Alright, the third step is you're going to plug in your point xy into the equation of the line and solve for y. Okay, now I'm going to split the page into two because I'm going to do both the tangent and the normal on the same page. So third step in finding the equation of the tangent is plug in x and y into the equation of the line and solve for y. And I mean, you've done this before, I'm just going over it again. And what's the equation of a line, of any line? It's y minus y1 equals m, parentheses x minus x1. Alright, so just plug in where you see y1 put in 4, where you see x1 put in 1. And the slope is negative 8. Alright, go ahead and get in the house. So that's going to be negative 8x plus 8. Take the 4 to the other side, so that's going to be negative 8x plus 12 because it's going to be 8 plus 4 is 12. And that's the equation of the tangent line. So this is nothing new. You've done this a million times. Just a quick refresher. Really the new thing is what the equation of a normal line is. So I'm just going to do a second example here. And if you can't make it fit, just go on to the next page. You know how to do it. I always make mine fit. Alright, so find the equation of the normal line to that same thing. That same equation that we just did at the same point x equals 1. I just want to show you what the difference is between the two. Alright, so first step is going to be follow the same steps 1 and 2 as you did above. So it's just like the tangent, in steps 1 and 2 is the same. And then the second step, this is where it differs, is you're going to find the perpendicular slope. Right? Remember, we found the slope to be negative 8, but now we're going to find the perpendicular slope. Well, to find the perpendicular slope, you have to flip and change the sign. Flip and change the sign. Flip and change the sign. So you start off with negative 8, And you can make that into a fraction by saying negative 8 over 1. And then you're going to flip it and change the sign. So you start off with negative 8 over 1, flip it, becomes 1 over 8, and change the sign. So the sign changes from negative to a positive. So the slope of the normal line is 1 over 8. And then you do the exact same thing you did in step 3, which is going to be plugging it into y minus y1 equals mx minus x1 and solve for y. So where you see y1, you're going to put 4. Where you see x1, you're going to put 1. Only this time the slope is 1 over 8. So you're going to get y minus 4 equals 1 over 8, and then x minus 1. So that gives me, so you're going to get y equals, and I'm going to take the negative 4 to the other side, but I'm also going to get in the house. So 1/8 x, and then 1/8 times negative 1 is negative 1/8. And then we're going to add the 4. So that simplifies to y equals 1 over 8x plus 4 minus 1/8 is 3 7/8. And actually, instead of me writing 3 7/8, I'm going to make it into an improper fraction just because that's how I usually see it done. So that's going to be 8 times 3, 24 plus 7, 31. So 31 over 8. So I'm just going to erase that. I put 31 over 8. And that's it. So that's how you find the equation of a normal line. All you need to remember is the slope is perpendicular to that of the tangent line. So the tangent line is the derivative, and then the equation of a normal line is perpendicular to the tangent line. All right, so again, the only difference in the steps is with a normal line, you must flip the slope and change the sign before plugging it back into the equation of a line. So let's take a look at another example. So find the equation of the tangent and normal line to the curve. Y equals x squared times x minus 2 cubed at x equals 1. So again, the very first thing that you're going to do is you need to find a particular point, xy, and you're only given x, right? So you need to find the y coordinate since you only have the x. So all you have to do is plug in where you see x put 1. So 1 squared and then 1 minus 2 cubed, and that's going to give me 1 times negative 1 cubed, which is equal to negative 1. All right, so that means my y value is negative 1. So my coordinate is 1, negative 1. So x1, y1. All right, then the second thing is you need to find the slope, find the derivative. All right, so finding the derivative of this, it's a product function, so it's going to be 2x. So derivative of the first thing, which is 2x, times the second thing just as it is, plus the derivative of the second thing, which is going to be 3 times the parentheses squared, and then the derivative of the inside, which is just 1, times the very first thing, which is x squared. Alright, so again, derivative of first thing times the second plus the derivative of the second thing times the first. Alright, then let's simplify this a little bit and see what it looks like. So we're going to get, the first part stays the same, but the second part we can combine the 3 times x squared to get 3x squared. Alright, so it's pretty straightforward. Alright, so now we are doing it at this point that we're given. So what's the slope at x equals 1? So all you got to do is plug in 1 where you see x, so that's going to be 2 times 1. And then 1 minus 2 is negative 1, so negative 1 cubed, plus 1 squared, which is 1 times 3, which is 3, and then 1 minus 2 is negative 1, so negative 1 squared, and that's going to give me negative 2 plus 3, which is equal to 1. So my slope at x equals 1 is 1. Alright, so to find the tangent line all you have to do is plug that into the formula that you already know, y minus y1 equals mx minus x1. And you're plugging in x1 is 1 and y1 is negative 1. So it's y minus negative 1 equals a slope, which is 1, x minus 1. Go ahead and get in the house and distribute. So it's going to give me that, and then take the positive one to the other side, it's going to be negative 1. Alright, so my final answer, the equation of the tangent line, is y equals x minus 2. You're going to do the same thing for the normal line, the only difference again being that you take the slope of the tangent, you flip it, and you change the sign because it's perpendicular to the tangent line. So you start off with the normal line, and you have the slope, which we found out to be 1. So we're going to make it a fraction by saying 1 over 1. So you're going to flip it, which is going to be 1 over 1 still, and then change the sign, so it's going to be negative, and then simplify that to negative 1. Now you do the equation of the line just as before, y minus y1 equals mx minus x1. Only difference is now the slope is not 1, it is negative 1 because it's the slope of the normal line. And so that's all you're plugging it in. Go ahead and distribute. So you're going to get y plus 1 equals negative x plus 1. take the positive 1 to the other side, it's going to be minus 1, so you're going to get y equals negative x. And now that's the equation of the normal line. Okay, so again, the biggest thing to remember is tangent line and normal line, they're perpendicular to one another. Normal line is perpendicular to the tangent line. Let's take a look at one more example and make it a little bit tougher. This is a listening check. Color in example 4. Color in example 4. Step 1 again is find the coordinates if you're not given both of them. So plugging in negative 1 for x, you're going to get y equals 0 over 1, which is 0. So your point, your coordinate is negative 1, 0. So that's x1, y1. Find the slope of the tangent line, which remember the slope of the tangent line is just the derivative. Slope of the tangent line is the derivative. Slope of the tangent line is the derivative. I mean, if there's one thing you should know in this class, is slope of the tangent line is the derivative. So you're going to do low d high minus high d low over low squared. You don't really remember how to do that, just go back a couple of videos where we did differentiation of quotient rule. And so low is 2x plus 3. Derivative of high is 2x minus high, which is x squared minus 1, times the derivative of low, which is 2, all over low squared, so that's 2x plus 3 squared. And I don't write it there for whatever reason, but that's a listening check. Go ahead and put the squared there. Alright, so then you're plugging in negative 1. So where you see x, just plug it in. Don't even bother simplifying, just plug it in. So you're going to get 1 times negative 2 minus 0 over 1 squared, which is 1. And then that simplifies to negative 2 over 1, which simplifies to negative 2. So that's the slope of the tangent line. Then all you have to do is plug it back into y minus y1 equals mx minus x1. So your x1 is negative 1 and your y1 is 0. For the normal line, you have to find the slope, the perpendicular slope. So you start off with what you're given. So negative 2 over 1, flip it. It's going to be 1 over 2. Change the sign from negative to positive. So that's your slope. And then you're going to do the same thing with that as well. Alright, so just plugging it in for both the tangent and the normal line, you're going to get y minus y1, which is 0, equals the slope for the tangent, which is negative 2, and then x minus x1 is negative 1. Getting in the house, you're going to get negative 2x minus 2. And that's it. That's the equation of the tangent. The equation of the normal, same thing. Y minus y1 is 0 equals m, which is this time 1/2, x minus x1, which is negative 1. Getting in the house, y equals 1/2 x plus 1/2. Right, and that's pretty much all there is to it. Alright, so let's just practice and get really, really good at it, because this is a really easy question to get.
Say we never do, but we made it. We made it. We made it. Say we never will, but we made it.